Hello everybody, let's continue on with our discussion of section 2.2, and this time we've got a few more complex equations to solve, and this time what makes them more complex is the fact that we have variables on both sides of the equation. So we should ask ourselves, well, what should we do first here? Because clearly we have to isolate our variable x to one side and any term that does not have a variable to the other. A good general strategy is to always start by simplifying both sides of the equation, something we'll have to do at problem number 6 here. But let's look at problem number 5 first for a basic idea. If I have a variable on both sides of my equation, I'm going to handle this situation by gathering like terms to one side of the equation. We do that by addition and subtraction. So I'm going to subtract 3x from both sides of the equation equally. So I'm going to subtract 3x from the left and 3x from the right on my equation to balance the equation. This has the effect of taking 5x minus 3x, giving us 2x minus 4 on the left-hand side. And of course, when we take positive 3x and negative 3x, that gives us 0, so that eliminates the variable term on the right, leaving us with negative 10. Our next step would be to combine our like terms. That is, gather the constants to the right-hand side. We're going to do this by adding 4 to both sides this time. So let's add 4 to the left, add 4 to the right. And when we do that, of course, we end up with 0 on the left in its place. So we've got 2x plus 0, or just simply 2x, is equal to negative 10 plus 4, which would be negative 6. Finally, we want to isolate our variable by division. So we're going to divide by 2 on both the left and the right-hand side, and this gives us x equals negative 3 as our solution. Now, whenever we have a more complex type of equation, it's usually to our benefit to make sure that we check that. So let's do that really quickly right here. Does negative 3 actually solve the equation? And we check that by direct substitution. So let's put negative 3 into the left. And negative 3 into the right. Doing so gives us negative 15 minus 4 on the left, negative 9 minus 10 on the right. Of course, by combining these two together, we get negative 19 on the left. And sure enough, we get negative 19 on the right, so we've found the correct solution. Well, what about this guy, number 6 over here? Well, it's a little bit more going on, but the same type of principles will apply. Before we start doing anything, though, the very first step is to simplify on both sides. We simplify expressions by combining any like terms, by getting rid of parentheses if they're there, and joining together any terms that can be joined together so that we'd only have a simple equation, at least to the extent that we have in number 5 right here. So simplify on both sides is always the first step if it needs it. So simplify on both. Not very good both, but it'll work. Sides. All right, so let's see. In this case, on the left-hand side, we've got 9x minus the quantity 2x plus 5. If it helps you to think of it, this is exactly like saying 9x plus negative 1 times the quantity 2x plus 5 on that left-hand side. And thinking of it that way allows us to see that we should distribute the negative 1 not to just the 2x, but to both terms, 2x plus 5. So we're going to end up with 9x minus 2x minus 5 on the left-hand side. And that's not coming out too good. My pen's leaking again here. Let me try that again. Minus 2x minus 5. Now on the right-hand side, we've got 4 times the quantity 5x plus 2. So just like we did on the left, we need to distribute the 4 on the right to both terms in the parentheses, giving us 20x plus 8. So let's see, let's do a little subtraction right here. 9x minus 2x gives us 7x, combining our like terms. and that's equal to 20x plus 8. Well, not too bad. This is just like the one on the left, so let's start gathering some like terms. I always gather my variable terms to the left-hand side. You can gather them on any side that you want, but I'm going to subtract 20x from both the left and the right-hand side equally to balance my equation. We get 7 minus 20, which is negative 13 times x, minus 5 is equal to 20x minus 20x. That goes away, giving us positive 8 on the right-hand side. So now we're going to add 5 to both sides to gather our constants. Plus 5 give us negative 13x equals positive 13. So finally, to isolate x, we are going to need to divide both sides by negative 13, both on the left and on the right. And we can see that the result of doing so is to give us negative 1. Again, it's a more complex equation. It's worth our time to check. We always check by going back to the original equation. So we're going to do that. Let's substitute in negative 1. Anywhere we see x, we've got a quantity, 2 times negative 1 minus plus 5, pardon me. And that will be equal to 4 times 5 times negative 1 plus 2 over here. So let's see, there's negative 9 minus, let's see, 2 times negative 1 plus 5. That's negative 2 plus 5. And that's 4, negative 5 plus 2. So we end up with negative 9 minus 3 equals negative 20 plus 8. Well, let's see, negative 9 minus 3 is negative 12. Well, negative 20 plus 8 is also negative 12, so that checks out. And we're done.